day everyone, I am Maria Salvarina of the Set 3A. And now I'm going to give my reflection or my understanding about the topic in meteorology from Unit 4 to Unit 6. What are you waiting for? Let's begin. Unit 4 entitled Air Masses or Fronts. So, what is air pressure? The air around you has weight and it presses against everything it touches. That pressure is called atmospheric pressure or air pressure. It is the force exerted on a surface by the air above it as gravity pulls it to Earth. Atmospheric pressure is commonly measured with a barometer. In a barometer, a column of mercury in a glass tube rises or falls as the weight of this atmosphere changes. Meteorologists describe the atmospheric pressure by how high the mercury rises. Next, what is air mass? Air mass are large bodies of air that have similar temperature and humidity. Air masses play a big role in weather. At the boundaries between air masses, weather fronts form. Weather fronts cause changes in the weather such as rain, storms, and winds. Meteorologists study air masses and weather fronts to help make predictions about the weather. Parts of Earth's surface that are particularly suited to generate air masses because they are expensive, physically uniform, and associated with air that is stationary or anticyclonic. There are 4 central regions classified according to their latitude: Arctic or Antarctic air mass, polar air mass, tropical air mass, equatorial air mass. A capitalized initial identifies each of these regions. It means A stands for Arctic or Antarctic, C stands for polar, C stands for tropical, and E for equatorial. So we have 6 primary types of air masses covering the planet emerge when you combine the source region with the kind of surface underlying an air mass. First is the continental Arctic or CA, continental Antarctic or CAA, continental polar or CP, maritime polar NP, continental tropical CP, maritime tropical NC, and maritime equatorial NE. Moving on to what is fronts and its 4 types. So what do you mean by fronts? Fronts are boundaries between air masses of different temperatures. Fronts are actually zones of transition, but sometimes the transition zone, called a frontal zone, can be quite sharp. The first type of front is a stationary front. So, the common boundary between 2 air masses in a situation in which neither air mass displaces the other. A front that barely moves with winds blowing in almost parallel, but in opposite directions on each side of the front. Next, we have a cold front. The leading edge of a cool air mass actually displacing one air. The leading edge of a relatively colder air mass which separates 2 air masses in which the gradients of temperature and moisture are maximized. The third one is the warm front. The leading edge of an advancing warm air mass, a front that moves in such a way that warm air replaces cold air. And lastly, the occluded front. A complex front formed when a cold front overtakes a warm front, lifting all of the warm air mass off the ground. So we are going to talk about Unit 5 entitled Under Pressure. Most of the time when we describe what's happening within the atmosphere based on the atmospheric pressure, what we do is we describe one of the fundamental types of air pressure systems, which are high pressure system and low pressure system. So first we have low pressure system. A low pressure system has a center with lower pressure than the surroundings. When winds blow in the direction of a low pressure area, the air with the heat rises in the atmosphere. The water vapor in the air condenses as it rises, creating clouds and frequently precipitation. The Coriolis effect and the Earth's rotation with the low pressure system winds eastward, south of the equator clockwise and north of the equator counterclockwise. This is known as a cyclonic movement. A low pressure system is identified in weather maps by the red capital letter L, while a high pressure system has a center with more pressure than its surroundings. From areas of high pressure, winds blow. The wings of a high pressure system revolve counterclockwise south of the equator and clockwise north of the equator, and the opposite direction from a low pressure system. This flows is referred to as anticyclonic. Higher system air in as air is blasted outward. The void left behind is filled by the atmosphere. On a forecast map or weather map, a blue letter H signifies the position of high pressure system can be visible. So there are 5 factors affecting air pressure. First, temperature. Second, height from sea level. Third, moisture in air or humidity. Fourth, gravitation on Earth. And lastly, the rotation on Earth. As air is present on the Earth, it may be distributed into 2 ways, namely horizontally and vertically. Horizontal distribution. This distribution is the distribution of atmospheric pressure over the globe is known as horizontal distribution of pressure. It is shown on maps with the help of isobars. An isobar is a line connecting points that have equal values of pressure. The horizontal distribution of atmospheric pressure is not uniform in the world. It varies from time to time and at a given place. It varies from place to place over short distances. Vertical distribution air is a mixture of various gases. It is highly compressible. As it compresses, its density increases. The higher the density of air, the greater is the air pressure, and vice versa. So the mass of air above in the column of air compresses the air under it, hence its lower layers are more dense than the upper layers. As a result, the lower layers of the atmosphere have a higher density. Hence, it bears more pressure. Conversely, the higher layers are less compressed and hence they have a low density and low pressure. In my last understanding about Unit 6 entitled Weather, so what is weather? The term weather refers to the temporary conditions of the atmosphere, the layer of air that surrounds the Earth. The weather affects us in many ways. Day-to-day changes in weather can influence how we feel and the way we look at the world. Severe weather such as tornadoes, hurricanes, and blizzards can disrupt many people's lives because of the destruction they cause. So what makes the weather? There are 6 main components or parts of a weather. They are temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. Together, these components describe the weather at any given time. These changing components, along with the knowledge of atmospheric processes, help meteorologists, scientists who study weather forecasts what the weather will be in the near future. Weather systems. Cloud patterns indicate the presence of weather systems which produce most of the weather we are familiar with. Rain, heat waves, cold snaps, humidity, and cloudiness. Weather systems are simply the movement of warm and cold air across the globe. These movements are known as low pressure systems and high pressure systems. Move on to history of weather forecasting. In all of the cultures, weather forecasting became associated with religion and spiritualism. Weather such as rain, drought, wind, and cloudiness were associated with the deities or gods. These deities were worshipped in order to ensure good weather. Rain gods and goddesses were particularly important because rain influenced agriculture and construction projects. Tlaloc or Aztec, Set or Egyptian, and Indra or India, as well as Thor or Norse, Sis or Greek, and Shango or Yoruba, are only some gods associated with rain, thunder, and lightning. Development 17th and 18th centuries made weather forecasting more accurate. The 17th century saw the invention of the thermometer, which measures temperature. and the barometer, which measures air pressure. In the 18th century, Sir Isaac Newton was able to explain the complex physics of gravity motion and thermodynamics. Since the late 1930s, one of the main tools for observing general conditions of the atmosphere has been the radiosonde balloon, which sends information needed for forecasting back to Earth. A weather station is simply a facility with tools and technology used to forecast the weather. So there are different kinds of thermometers, barometers, and anemometers which measure wind speeds that are found at weather stations. Weather stations may also have computer equipment that allows meteorologists to create detailed maps of weather patterns, and technology that allows them to launch weather balloons and AMDR instruments gather information about temperature, pressure, humidity, and wind from very high levels in the atmosphere. Meteorologists input the data to computers and use it to map atmospheric winds in jet streams. They often combine the data about temperature, humidity, and wind recorded at the ground level. This complex weather map using Geographic Information Systems, or GIS, technology can calculate how weather systems are moving and predict how they might change. This type of forecasting is called synoptic forecasting. Synoptic forecasting is getting a general idea of the weather over a large area. It relies on the fact that in certain atmospheric conditions, particularly weather conditions, are usually produced. Move on to radar. It's another major tool of weather observation and forecasting. Radar used primarily to observe clouds and rain locally. One type of radar, called Doppler radar, is used at weather stations throughout the world. Doppler radar measures changes in wind speed and direction. It provides information within a radius of about 230 kilometers for 140 miles. Conventional radar can only show existing clouds and precipitation. With Doppler radar, meteorologists are able to forecast when and where severe thunderstorms and tornadoes are developing. There are types of weather: sunny, cloudy, windy, and rainy, or snowy. So, I have here an image above of weather forecasting symbols and their meanings, so you can take a picture and read the meaning of the different symbols that's used in weather forecasting. So, I have so many pictures of that. So, that's all. I hope you enjoy about my understanding in this subject, meteorology. So that's all. Thank you and God bless you.